Hello, my name is Jean-Luc Camilleri and I was born in 1958. I live in southwest of France in the countryside. Very young, I became interested in the study of religions and symbolism. At 16-year-old, I started a 2-year training in the fields of electricity, electronics, electromagnetism and automation for the government. Many years later, I studied robotics and productivity. I've traveled a lot and have had unusual experiences in Egypt, Israel, the Caribbean, the Indian Ocean, and others. The subject of the day. Today, I choose to surprise you right off the bat with a problem that has haunted the brightest minds of the past 3 millennia. Squaring the cycle. Nothing less. What is it about? Reproduce a square and a cycle with the same area. As you know, the area of a square is c squared, where c is the length of the sides. No major problem here. But the area of a circle, or if you prefer, of a disk, is 2 by pi by r squared, where r is the length of the radius and pi, for maths, represents the constant ratio of the circumference of a cycle to its diameter. The problem then comes from the fact that this number is said to be irrational, that is to say, that its constant value has decimals at infinity. It equals 3.1415926 and so on, which makes the equation c squared equals 2 by pi by r squared, without satisfactory solution because only approximative. My solution. It was therefore necessary to get rid of this irrational number pi. This is what current knowledge about high-energy physics, gravitational fields, and relativity has allowed me to do, and I just show it to you. Squaring the cycle, a true solution. Introduction. The squaring of the cycle has been pretentious idiocy for millennia, because during all this time, by working on a hypothetical Euclidean plane, we were going astray, because then we didn't escape the approximation of the value of pi. According to Einstein's relativity, a disk, no more than a square, cannot be perfectly flat any more than what is called Euclidean space. Hence, the indeterminacy at some level of decimalization of pi. We can even hypothesize that the calculation error of the areas made by laser sensors and power computers can, on the Euclidean space, correspond to the approximative of the calculation of pi, made using mathematical processes for an impressive numbers of decimal places. Development. Thus, we will always find in various space-times of the cosmos a domed disk D, whose area 2 by pi by r squared, where r is the length of the curved radius, is equal to the area of a curved square c squared, where c is the length of the curved side, such as area of the square equals the area of the circle, when projected into an Euclidean space plane in a spot on Earth. At this moment, 2 by pi by r squared equals c squared. These moments t prime and t second, seen from Earth, may appear before or after t, but their projection at this instant t on an Euclidean space would mean that their surfaces would be perfectly equal. Notwithstanding the fact that E prime and E second are curved, deformed spaces due to gravitational fields. Notwithstanding also the observation that the imprecision of the calculation of pi by a modern computer could be equal or less than that inevitable curvature of any physical and not theoretical Euclidean plane. QED. Conclusion. This resolution of the problem of squaring the cycle can only be understood by taking into account the phenomena of gravitational fields, relativity, and Einstein space-times, as well as those of modern physics, high-energy domain. Bertrand Russell said, mathematics can be defined as a science in which you never know what you are talking about or if what you say is true. Thank you for your attention, and see you soon for, I worked about a new test of Turing, following all the new technologies, and I want next to show it, to explain it, so you can become a follower or a member, and you'll know everything about that. Thank you very much. Bye-bye.